Hi everyone, this video is the first video for section 6.3. The warm-up you should try on your own. Yeah, try that on your own. So we'll get right into the lesson. So 6.3 is logarithms and logarithmic functions, which is probably something that you have not heard before. So that's why it starts out with, what is a logarithm? So it says every exponential function. So exponential functions are what we've been talking about in 6.1 and 6.2, right? This is an exponential function. I think I'm going to put this a little bit closer here for you to see. Okay, that's an exponential function where your variable was an exponent. So this is what we've been looking at. B to the x. So it says every exponential function has an inverse function that you can denote. G to the x, the way you would read this is equals log base b of x. So the inverse function is called a logarithmic function with a base b. So this little tiny subscript that we will end up writing there, it will be a number, that is the base. So the inverse of a exponential is a logarithmic function. So inverses, you might remember, are x squared. The inverse of x squared is the square root of x. So when we're solving, you use the inverse to undo something. So the inverse of an exponential is a log. Log is an abbreviation for logarithm. So here's kind of explaining it graphically. This is the graph of 2 to the x, right? We're used to looking at those exponential functions. You're used to saying this is growth. This is the inverse of that function. So the inverse of 2 to the x is going to be log base 2 of x. So you'll notice this exponential has a base 2, and this log, that's its base, it's that little tiny subscript, has the same base. You might also notice, so that's what this says down here, same base of 2. And graphs are flips, or you can think reflections, if you remember that from geometry. If I take this graph and I reflect it or flip it over the line y equals x, that will give me the graph of its inverse. That's true for all inverse functions. Their graphs are reflections about the line y equals x. So let's start looking at, first of all, a little formal definition. This is right out of your book, everything that I just talked about. So I'm going to jump down right to this part where this kind of goes into the different forms of logarithms you might see. So the first one is the one that we had on the other page. This is a logarithm of y with a base b. So there's my base, that little subscript. This is the equivalent exponential function, or the inverse that goes with this logarithmic function. There are also what we call the common log. Those have a base 10, but when we're writing the common log, we don't write the base. So this is what a common log would look like if you've seen it written. The base is an invisible base 10. So if you don't see a base, then it's 10. And then also on your calculator, you have a log button. That's always the common log or a base 10. So the calculator log is always a base 10. And then the equivalent here would be 10 to the x equals y. And then the other one is called a natural log. We'll talk about this more later. That is ln. And it stands for natural log, and so this would be natural log of x equals y. This has a base of e, so e to the x equals y. So the first thing we need to know is how to rewrite. If you're given a log, how to rewrite it as an exponential, or if you're given an exponential, how to rewrite it as a log. The reason we need to learn this is when we get to where we're solving equations with logs or exponentials. So this says rewrite each equation in an exponential form. So that means our answer is going to look like the big base to the x. Or, for example, our answer will be an exponential function, what you're used to seeing in 6.1 and 6.2. Starting with a log, going to an exponential. The first thing you should realize is the bases will always be the same. So if this has a base 2, your exponential is going to be a base 2. And then here's the little arrow trick that I use when I'm rewriting. The first arrow goes from the base across the equal sign to the number on the other side of the equal sign. And for your rewrite, you're going to say 2 to the power of 4. So the first arrow is everything on the left side of the equal sign, and you're going to put your equal, and then you're going to draw another arrow that points to that other number you haven't used yet. So you're going to say equals 16. So 2 to the power of 4, it's always going to be to the power because you're writing an exponential. 2 to the power of 4 equals 16. So this log has a base 4. That means my exponential is going to start with a base 4. And it's going to be 4 to the 0 equals, after the first arrow, that's when your equal comes in. What does it equal? 1. And these make sense, right? Anything to the 0 power is 1. 2 times 2 times 2 times 2 is 16. These make sense. This one is, base is 12. First arrow, 12 to the first power equals 12. Try it again. 6 to the third power equals 216. The nice thing about this arrow trick is it works, you'll see in a second, when we go the other way, when we're going from an exponential to a log. So there's a couple for you to try. Pause the video, try those. If you're coming back, what you should have had for this one is that, and for this one, you should have had that. Okay. Oh, you got some more. There's a couple more of your turns. That's a 1. Okay. All right, here's another example. It says a few trickier ones. They're not really that much trickier, but same thing. This has a base 10, so my exponential is going to have a base 10. 10 to the third power equals 1,000. Little trick about the tens to an exponent. 10 to the third power is going to be a 1 with 3 zeros. I think I told you that earlier in the last unit. This is 5 to the negative 1/2. 5 to the negative 2, sorry, I said that wrong, equals 1 over 25. Now, if you think about this, this makes sense. Because in our introduction unit, we said, what do we do with negative exponents? Well, we send it downstairs. 1 over 5 squared is 1 over 25. So those are equivalent. 5 to the negative 2 equals 1 over 25. 10 to the power of 0 equals 1. Yep, anything to the power of 0 equals 1. And this one is, the base is 1/4. So I'm going to say 1/4 to the negative 3 equals 64. Another thing you might notice on these is this number on the other side of the equal sign always ends up to be your exponent. The bases are the same. This ends up to be your exponent, and what you're taking the log of ends up on the other side of the equal sign. So let's see if this makes sense. If I share that -3 with everything in the parentheses, they're both unhappy, so I move both of them. 4 to the third is 64 over 1. Well, that's just 64. So this makes sense. Okay, these are for you to try, just 2. So pause the video and try those. And that should have been what you got for those. Okay, now the next set, we're going the opposite direction. If you look ahead, we're given exponentials, and what does it say? It says rewrite in logarithmic form. Well, if you're rewriting in logarithmic form, you know you're going to have the word log for starters, pretty much in all of these. So you could fill in log, log, log here. This is an exponential with a base 2, so I'm going to put the little 2 subscript. Make sure you write it small and as a subscript so it doesn't look like the number you're taking the log of. And the arrow trick works here too. So first arrow is log base 2 of 144. There's a mistake in this. This should be a 12. Make that a 12 because 2 to the second power does not equal 144. 12 to the second power equals 144. So this should be log base 12 of 144 equals 2. So the arrows still work, but you're starting out with log base 12, 144 equals 2. Right, the word log, I'm rewriting it as a log, so I need to start with the word log. Log base 20 of 1 over 20, so the base, this is a base 20, becomes my little subscript. Log base 20 of 1 over 20 equals -1. So here's the exponent on the other side of the equal sign, just like we had up here. We said the number on the other side of the equal sign becomes the exponent. So this is log. The base here is 216 of 6. So there's my small little subscript 216 of 6 equals 1/3. Rewriting as a log, so I need the word log. Log base 4 of 1 equals 0. Okay, try these. Pause the video, try those. Is there one on the other side? Yep, there's 4 of them. So try all 4 of them and then come back and check. Yeah, it should be what you got for the first 2. And for these, so again, when you're writing these, make sure this looks like a base of the log, a small number. Don't write it up here big next to these. I think we'll save this for the next video.